So we have here a slightly more complicated circuit, and I've got my Ohm's law equations already written down here. So let's begin like we usually do with writing down what is given. So we have a 45 volt power source. Our first resistor is 4 ohms. Our second resistor is 4 ohms. Our third resistor is 8 ohms. Our fourth resistor is 10, 4 ohms, 2 ohms, and 2 ohms. So the first thing we want to do is find our total resistance, and to do that we have to basically we have to see we have here a 2 ohm resistor and a 2 ohm resistor. So the equivalent resistance here will be 4 ohms. Our 5 ohm resistor, our 4 ohm resistor stays by itself, and over here we have a 4 ohm and an 8 ohm resistor, which will be the equivalent of a 12 ohm resistor here at this branch. So what we have to realize now is this 4 ohm resistor over here on the right and the 4 ohm resistor over here on the left are parallel to each other. And so if we do our inverse of 4 plus the inverse of 4, we end up with 1/2. If we take the inverse of that, well, then the total resistance here is 2 ohms. So for this branch right here that includes these resistors, the equivalent resistance is 2 ohms. Now, this 2 ohm equivalent branch over here is in series with this 10 ohm resistor right here. And so the equivalent resistance from here, to include all of that, is 12 ohms of resistance. So we have this, we have a branch right here, the branching point right here that includes all this, and the other branch goes down here. So this 12 ohm resistor here and this 12 ohm resistance equivalents over here are in parallel, and so we just have to take our inverse of the 12 plus the inverse of the 12, and we find out that the total resistance there that includes all this is 6 ohms of resistance. So all that comes after the R1 resistor, the 4 ohm resistor, and so our total resistance for the entire circuit is the 4 plus 6, which is our 10 ohms. So I'm going to record that up here for our total. So I used all this to determine that. So now anytime you have 2 of the 3 horizontally, you can solve for the third one. So we have I equals V over R. 45 divided by 10 is 4.5 amps. And I got that once I found that. Now, once I got this and I realized we have 4.5 amps coming out of the battery, well, then I know that that 4.5 amps is also going through this first resistor. And so because I know that, I'm just going to write that right here. And that allows us to solve for our voltage for our first resistor. So voltage is I times R, so 4.5 times 4 gives us 18 volts. So we now know that this resistor right here is 18 volts. What that means is for the remaining circuit, the rest of the circuit, we start with 45 volts, we lost 18 volts. So from here on out, these two branches right here are going to be, well, the remaining voltage. So if we take our 45 volts and subtract our 18 volts, then the remaining voltage is 27 volts. So that's for this branch right here, as well as this branch starting right here all the way to, well, basically down here. So what that means is from this X to this X is 27 volts. So we know that this whole branch is 27 volts. We know that the total resistance is 12 ohms. And so if we use our current equation, voltage divided by resistance, 27 volts divided by 12 ohms of resistance will give us the current going through this branch right here. So the current going through this branch right here is 27 divided by 12, which is 2.25 amps. So that means going through the R2 resistor and the R3 resistor is 2.25 amps. It'll be the same for both. Oops. Let's quick fix that. Now I've got that, so we've got 2 of the 3, so once again voltage is just current times resistance, so that gives us 9 volts and 18 volts respectively. I lost a 1 there. We're going to use the same idea as we just did from here to, well, here still, I guess, I'll just kind of mark it there, is going to also be 27 volts because that branch we just looked at and this whole branch are parallel to each other. You had a choice, a branching right here. So this whole thing is in parallel to this branch right here. The equivalent resistance is from here to here is going to be, that includes all these resistors, is going to be 12 ohms of resistance as well. And that was the same resistance as the other branch, but let's just work it out. So the current for this particular branch is also going to be 27 volts divided by our total resistance for this branch, which is 12 volts. And as we already know, I'll just try to squeeze this in right here. That means that the current going this direction is also 2.25 amps. That includes this resistor. That current will get split up again right here at this divergence, but I'm going to record this right now here, 2.25 amps. And now we have 2 of the 3, so I'm going to use this to solve for voltage, and that will be 22.5 volts when I take the current times the resistance. So we started with 27 volts and it took 22.5 volts to go across this resistor. That means the remaining voltage from here to here will be the difference. So I'll take my 27 volts and I'll subtract my 22.5 volts, and that leaves me with 4.5 volts from the green X's to the green X. So going across this branch will be 4.5 volts, and across this branch will be 4.5 volts. Because they're in parallel, they're going to have the same voltage. This resistor by itself will have 4.5 volts going from one side to the other. We know its resistance, and so we can actually figure out R5 right now. R5 is 4.5 volts, and now that we know that, we can figure out current by dividing. And to do that, we get, or when we do that, we get 1.13 amps for that resistor. So that leaves us with our last branch. We know that going from, I'll just draw this again in black, because it's the same, it's the other branch of this group here. So going from one side to the other is going to be, add up to be 4.5 volts total from there to there. We know the total resistance is 4 ohms, and so to find our current, we just take that 4.5 volts divided by our total of 4 ohms, and we now know that the current going through these two resistors is 1.13 amps. So I'm going to write that in here right here. And that means that we can solve for voltage just by multiplying. And so 2.25 volts to multiply those two. And hey, they're the same amount of resistance, so that means it's going to be the same amount of voltage, which should make sense. So we have successfully solved the entire VI&R part of this chart. Power is just going to be current times voltage, and that'll be a good check when we're done, just to make sure everything works out correctly. So when I'm just going to go across and fill these in, multiplying our voltage times our current. It's supposed to be an X. So when I do that, I get 202.5 watts, 81 watts, and 2.5. And the check comes is when you add all these together, it really should equal the total. And if you check, it's pretty close.